In this video, we'll be talking about unit testing in Python. In the last video, I already showed you how to use git branch and merge. So in this video, I'm going to build on top of this one to add some new functionality to the package, and we'll be adding unit testing to the package. We'll be using the GeoDemo. Again, you can clone the repository to your computer, or you can use your own repository. And I'm just going to open my Visual Studio Code. So this is the package, and first of all, you need to make sure that what kind of branch you are on right now. So you can just type git branch. So this one right now here, we are using the in the master branch, and we can create a new one. So just git checkout and dash b, then you can choose whatever name you like. So again, I'm just going to do unit test and then hit enter. Okay, so now we are switching to the git the unit test branch. Again, you can type git branch again. So the green color represents the current branch we're in. After that, we can start adding new files or whatever functionality we want to the package. So before we get into the detail how to do that, I would like to quickly show you, for example, some of the links that might be useful. You can just type Google unit test Python. You should be able to find this web page. The reason that we want to use unit testing is to actually to automate all the testing, because you have been developing all kind of functions for your package, and you also maybe use some Jupyter Notebook to test some of the functions. But that's not the best way. So think about it. After you have hundreds of functions, there's no way you can test everyone. So it's a good practice to develop some testing strategies that can automate the testing. So in that way, later if you make changes to a certain function, if it breaks something, you will know. Because otherwise, if you do manual testing, you might not notice some of the errors that are already there. So it's basically affecting your package. So make sure that everything works as expected, and you can develop a way to automate it, to automate the entire procedure. So in that way, you don't have to manually check all the functions. So if you have been following this tutorial series, you might already have the package that they were using the cookie character. So actually that one comes with the unit testing functionality. So if your repository right now have a folder directory test, and then if you click to see the contents inside, you should be able to see number of files, for example init.py, and also the test underscore, and then whatever name. So GeoDemo and the test utility, this one was the one that we added in the last video. But so in this video, we'll just simply work on this one, and you can create as many files within the test directory, but usually depends on how many modules you have. So for example, for this GeoDemo package, we have a couple of those, right? So for example, common and GeoDemo toolbar utilities. So ideal situation, you should have the same number of files in here. It will be test underscore common.py here, test GeoDemo, test toolbar, and test utilities. Make sure you start the file name with test underscore, otherwise it might not be recognized. So make sure you have all the files in here. After that, you can click this one. So let's add some new functions to, for example, to the utilities.py. So for here right now, we only have one function, random string, but we can add a few more. So then we can add some testing. To save time, I'm going to copy some of the script that I already developed under the other branch. So if you go to my GitHub repository and then click here the testing branch, and then click in utilities. So I already did a few more. So these are some like very simple functions: add, subtract, multiply, divide, right? So these simple functions that we want to do some testing. If you already have some other function, you can directly use your function. So what I need to do is just come here and then just paste, Control S. Okay, so in this module right now, we have 5 functions. How can you develop automated testing so that you can test all these functions without having to manually go through them or test these functions using Jupyter Notebook? What you need to do is, again, go to this test directory, and then from here you should be able to see, for example, test utilities. So this, because all the functions right now within this module, it's better to just write things within this module. So you just click here. This is the one that we used last time, and it basically has a framework, but it's not finished yet. If you look at this one right now here, we have a class. So it's a test utilities, and then unit testing test case. So test case basically is trying to test other functions with multiple cases, different info, for example. And also because this is a class, so within there we can have all kind of functions, and then we can basically test this class to make sure things work expected. Again, I already write some simple one testing. So we can go to again the geo demo, and then let me click the testing. So in my testing branch is actually under this the test demo.py. It doesn't matter. So what I'm going to do here is to simply just copy this entire string here, maybe just from the setup to the end, and then just right click copy and come back to here, just paste. Okay, and then Control S. Oh, you need to make sure you delete this one here. Control S. So look at this file. This is the way that you can use to develop automatic testing. So this is called unit testing. What unit testing means is that every function is basically isolated. So you are testing a function, and that function does not rely on some other functions, and it's basically just a single unit. If you look at here from the setup and tear down, so tear down means setup means if you have something that you want to run before all the testing are being run, you can put things within the setup, and after the testing done, if you want to follow something, then you can use the tear down. So this function, the setup and tear down, is the function that's going to be executed every time if you are testing something. So let's go back to the utilities function in here in this module. Right now we have 5 functions, right? So we're going to write test to test these all 5 functions. If you come back to the module here, let's look at the first one, test random string, right? So again, you need to start the function name with test underscore, and then from there, this one you don't have to exactly follow the name of the function, but it's recommended. So because in the module here we have the function called random string, like add, subtract, multiply, and divide. So we are doing exactly the same here, test, and then the name of the function, parentheses self, because every function right now is within this test utilities class. And the next one will be test add, test subtract, and test multiply, and test divide. So these are the things that the 5 functions. This is the function definition. And the next one here is so-called here the assert statement. So self.assert equal, and let me go back to here. There's some links in here that you might want to take a look. For example, there's a YouTube video very helpful. I can click here, and I'm going to show you here. This one here is the cert link. You can just Google unit testing and then debug. You should be able to find the function in here. These are some of the functions that it's very useful when you need to develop automatic testing. And the one we're going to use is assert equal. Assert equal, that means, okay, so if your function is producing a value or something, or an object, you want to make sure that it's within your expectations. So the result, for example, this is what the program is going to produce, and this is what the expected result. You can use this one to basically make sure that the result will be exactly the same. Otherwise, that means it's something is wrong with your function. Then we go back to here, take a look at the first one, self.assert equal, right? So within the equal, we have 2 arguments. The first one is the function you want to test, and the second one is the expected value. If you look at the utilities function like the random string, right? So this is the function here we're going to use. The random string they use to generate a random string with a limited specified number of characters. By default, it will be 3, right? But you can pass whatever number you're going to use. And so if you pass 3, that means it's going to generate a string with 3 characters, right? So if you use this function, the length, and then if you pass in within here, so if you use 3, the length should be it's expected to be 3. Otherwise, that means your function is not working as expected. So similarly, you can use the add test subtract. Here you can also have the print function. This is not required usually within the test function, but this one, it can, if your function is producing some values, then you can use assert equal. If it is true or false or something else, so these are the options you can have, right? True or false, is not, is none, is not none, and is instance. This is very useful that there's some scenario that you might not always use the assert equal, but in our case here we use this one. The next one here is test add, right? So add is very simple. I'm gonna add 2 numbers together. So if you come back to this one, utilities.add, right? So this is the function we're going to call -1 + 1. Okay, so the result should be 0. If any of those functions actually is not does not meet this criteria, it's going to fail. So if it fails, then you will basically show the your program is not working as expected. So then you need to look into your source code to see if you have accidentally break something or not. And so similarly, you can have multiple assert statements within one function, right? Because you want to test multiple cases. This is like negative, positive, negative, negative, like positive, positive. So if you develop a function, you want to make sure that you cover all cases. If you allow the user to enter something, to enter a string, or enter a number, if the user does not enter the correct format, you might know something here sometimes might throw out the errors. And so the test subtract, test multiply, and test divide, they are pretty much exactly the same, right? So you can have multiple together and you can use that to test your function. The last one here is also, in this case, test SHP to GeoJSON, right? So test, let me see here, SHP to GeoJSON. So this function actually comes from the GeoDemo module. So it's come from here. If you scroll down to see this one here, this one, so swap file to GeoJSON. If you develop this function, right, you want to test that, make sure if you provide an input swap file, you want to make sure that you get the result as expected, as output as a GeoJSON. So if you don't produce the result, then that means the function is not working expected. So similarly, we can do it here within this, but first you need to make sure that we also import the GeoDemo, right? So because we need 2 modules. But usually you want to separate, right? Test GeoDemo and also test utilities. But just for simplification, we are doing all of this within one single module. Lastly, we also have this one. If __ main name _ equal to _main _ means that, okay, if this module is being executed, it's going to use the unit test. If you don't have these 2 lines, keep it in mind here, if I Control/ and then Control S, if you press F5 on your keyboard, it's going to run, and then most likely you won't see any results because this is not being executed, right? You don't see any output here. This is just the command line to execute this one. But if you go to the GitHub workflow, so if you click the .github and then go to workflow build, if you scroll down to here to see this one, the last one here is actually running all the testing. So if you use the cookie character module to create your package, the automatic unit testing is actually already included. So if you write something, add something to here, when this package is being pushed to GitHub, it will run the testing. So if anything fail, then you need to fix the issue. This is the command that you actually need to do the testing. So what we need to do actually is to come to go to click this one here. Make sure you remember Python -m and then unit test, and then you can test whatever Python file you want to test under the test directory. So let's click this one more time, and then just type Python -m and then unit test, and then the test directory. Just hit enter, and it's going to show you, okay, blah blah blah. Let me scroll up here. Let's just do one file. So test and then test utilities. Hit enter. It's going to show you here input empty module name. So let's figure out what we need to do here. As you can see, it doesn't allow you to do that. So what you need to do is to actually add these two lines into the file and then Control S. Then if you just press F5 again, now you should be able to see the testing results. If you miss anything, then you can fix the error. So look at this one right now. Look at the error. It doesn't pass all the tracks. So it says name OS is not defined. If you go up here, os.pass. So because this one we're using the OS library, it's not found. So you need to go to the beginning of the file. Just import OS, Control S again, and then F5 again. And with F5, it might take a couple seconds. So now you see run 6 tests in less than 1 second. And so these are all the functions that have been tested. Set up and then the name of the function and then tear down, because this is just print out the message, but you can do whatever you need to do. You don't have to actually print out this one. Just to show you, this is just the implication that if you want to do something before each test is run, you can do that. The reason that we use this here setup in this case is input swap file. Let's say you have a file that you have a package that you want to test, and then all the testing largely depends on input file that's going to be the same across multiple functions. Then you can just put this one and then assign this one to an attribute of the class, right? Self, that means it's a class. And then later you can access this one within other functions, because this one is always executed before all the testing functions. So if you have an input swap file, then later in here, in this function test swap file to GeoJSON, you can directly access that attribute. So if you look at this one here, geodemo.shp to GeoJSON, right? So the input file here, we no longer need to pass the absolute file path, and that's nice because assume that you have multiple functions use the same input file. If you provide the wrong file path, you need to make changes to all cases, and that's not very convenient. So it's nice to have one single file. When every function is executed, then you can access the file as an attribute of the class. So here, assert instance, right? So earlier we used assert equal. That means you just basically check whether the result is expected or not. You can also assert its instance. That means, okay, if we provide a swap file and then ask to convert to a GeoJSON, and the GeoJSON is a type of dictionary. So if at the end the result is supposed to be returned as a dictionary, if somehow it fails, then you might return a none value. In that case, it's no longer a dictionary, so you might run into issues and you will fail. If you fail, that means something is wrong. You probably accidentally break something, then you need to go back to check. Again, let me quickly show you that what you can expect. For example, right? Let's go back to the random string function here. And so this one right now is fine because we generate a random string with 3 characters. The length is going to be 3. Let's go back to this utility function, and I can maybe accidentally I change something. So for example, in this case, a random string, and then I can go to the line here for I in range, right? If I accidentally, maybe I add another one, let's say add 1, Control S. So here, if you provide 3 in your function here, actually it's going to generate 4. That means 4 is not equal to 3. So if you run the testing, it's going to fail. So let's take a look at this one more time. F5. And okay, now it shows execute exception has occurred. Then you can go back to here to do the testing, the result. It will show you, okay, fail test random string. And so the result here will be assertion error 4 not equal to 3. So basically your testing failed, and this way you quickly know that, okay, then I need to go back to double check the function. Is this something wrong, or you accidentally add something? So 4 is not equal to 3, and we know it comes from this function, Okay, then we need to look at this one, and okay, this is the issue. You just delete this one, Control S, and you might need to stop the testing. Come back to here, the testing file again, F5 one more time, and now it should pass all the testing. So by the way, all the functions, testing functions within here, within this module, they are not in order. So when it's running the test, it doesn't mean that it's running from the beginning to the end. It's not. So it's actually random. If you see from the result here, set tab, right? So the first one, the function being tested is add, divide, multiply, random, SPA to string, and subtract, right? It's not based on the order that we put in here, so you want to keep that in mind. And that's the reason that you want, this is called the unit testing, because one function is testing singly on that function itself. It doesn't rely on anything else. Otherwise, because they're not run in sequence, if your function rely on a previous function, then you want to run into trouble, because that function might not have been executed. And this is the reason that you want to have the set tab and the tier down. Set tab means you can make sure that you have all the input set up properly before you run that function. So if you want to anything to be executed before that, you need to run things in here. So for example, and then after that, you can assign add as an attribute to the class input set file or whatever file you want to use. Then you can use that later in other functions. So this is kind of a nice way to for you to save some time if you have a file that's going to be used by multiple functions. Okay, so this is pretty just simple and easy. Most of the time we just use assert equal and then assert is instance, but there's a couple more functions here you can use. For example, true or false is, and then you can also, for example, raise error. So if you expect that it's going to raise an issue, you can also do that. So this is here in the test divide, right? If you divide something, let's go back to the utility function, right? So the divide, you are not supposed to divide something by 0. So if you divide something by 0, it's going to raise a value error. So when you're doing the testing, you can purposely divide number by 0, right? But within here, you need to use this way with self.assert raises value error. So this basically means, okay, if I run in this one, it's supposed to raise a value error, and indeed it's going to do that, because this is what we set up here in this function. And make sure that you understand this portion. So depends on how many functions you have in your package. The nice way is basically to test everything, but sometimes this can be quite challenging, because you can test the function whether it's going to produce some result or not, but sometimes it's more difficult to validate the accuracy of the results. So not every function can be fully tested, but you need to try your best to test the function, and then use the unit testing. So in that way, you are basically streamlined. You don't need to do manual testing, and every function should have, basically every module should have a testing somewhere in here with multiple inputs, so that you understand that basically cover multiple scenarios. And if a function fails, then you need to actually fix the issue. Okay, so once we add this, add all these functions, then we can, for example, merge the things to the master. So again, in Git branch, right? Right now we're under the unit test branch. We can switch to the master. So Git check out master. In the last video, let's go back here, because we need to commit the changes actually to the Git unit testing. So Git check out unit test. Okay, right now we're under this branch, right? So we can just edit unit test, control enter, and once we have control enter, that means it's been committed, and we can Git check out master. Okay, so once we're under master, right now the master is behind the Git the unit test. So what we want to do is to Git merge unit test, right? So we're going to merge things from the unit test branch to the master. So just control enter. As you can see, right now we have the green color. That means all the files, the changes have been merged into this one. So we should have this up and running. And after that, you can just simply git push. So you can click this one here and then just push. It should push all the changes to the GitHub repository, and from there you will be able to see that when the testing are being executed, whether it fails or not. So click the repository. Now it's being all the package is being built. So again, click the Git workflow and then the build. Right, so if you see here, this is going to be executed. It's just like when we testing this one here using our local computer using a Visual Studio Code. So GitHub is also going to help us to automate the testing. If you already have something developed in your package under here, these things are going to be tested. So in that way, you don't have to worry about if you accidentally break something, you will know. Otherwise, it might be difficult to capture because some of the things that you update, you might not always remember to what changes you need to make in order to make sure that if your previous example still works. And you can just wait. Okay, seeing all the tests right now looks fine. That means all the testing have been finished successfully. If you want to take a look at the details, you can click the details, and from here, if you click the PKG test, this is the one that tests all your examples. It's just like what we did earlier in Visual Studio Code, right? You will see here, setup, test add, and then tear down, right? Run 7 tests in how many seconds? That means all the functions pass the test, and we are good to go. So again, you might need to wait for a few more seconds before everything finished. If you see the green check mark, that's a good sign. If you see a red crosses, then you need to click the details to see what's wrong and how to do that. Lastly, I'm going to here just simply going to create a new release because I just add some new functions. So after you have add some new functionality, you might want to create a new release. Again, I can go to my GitHub repository, and then from here I can just use bump versions. Okay, BUMP and then I'm just going to bump a page. It can be minor, it can be major, so but I'm just going to bump a page, and then from here you can just git push this text, and then it's going to release the new text to right now it's 0.06, right? So from 0.05 to 0.06, then just git push. It's create a new new tag here on GitHub. So refresh, and here just still releases a 5. You need to click the releases, and then from here text, right? Text, and then on the right here you can click create new release. Okay, and from here I can just simply copy this one, and then in the description I can just say okay, add the unit test. Okay, and then you can publish release. After you publish, it's going to run the execution, so it's going to publish the new version to PyPI, and then you can install the latest version. If you click the actions here, the PyPI, this one right now is being executed. So once it's finished, then that means the new package will be available for PyPI, and everything that the new functionality you add to the package will be available for anyone around the globe to install your latest version. Okay, so it's done, and you can click the repository. After that, here you can open this one. Now you should be able to see 0.06, right? So if you install the latest one, you should be able to access the new functionality. You can also update your conda force, but for this one it's going to take some time. But I already saw your video in before how to actually also update this one. You need to do basically a pull request to update the changes, or you can wait for conda to send you an automatic pull request. Then you can just click and then merge the pull request. Then the conda package will also be updated. Okay, so that's all for this video, and I will see you in the next one. Take care. Bye bye.